Hi everyone. This video presents process. The subject name is operating system. First, what is process? A process is an instance of a program running in a computer. Okay, it is called as process. The different process states are available. So, ready state, running state, waiting state, terminated states. Okay. So, ready state is nothing but the process is waiting to be assigned to a processor that is called as ready state. Next, what is mean by running state? Instructions are being executed. Okay. Next, the process is waiting for some event to occur. It's known as waiting stage, okay, such as an input and output completions. Okay. Next one is the process has finished execution, that is called as terminated. Okay, these are the basic definitions for different process states: ready state, running state, waiting state, and terminated. Okay, so this is the process states. Okay, what is exactly computer process? There can be multiple instance of a single program, and each instance of that running program is a process. This is the basic definitions. Each process has a separate memory address space, which means that a process runs independently and is isolated from other process. Okay, it can't directly access shared data in other process. Okay, this is called as computer process. Okay, so what is meant by thread? This is the basic one. Okay, uh, uh, thread is a lightweight process that can be managed independently by a scheduler. Okay, this is called as thread. What is the process? What is the comparison between thread and process? So, thread is a lightweight process that can be managed independently by a scheduler. Okay, so exactly process means it is a program under executions. Okay, that means it is an active program. Okay, this is the difference and identifications between the process and the thread. Coming to the point, uh, so exactly process means it is a program under executions. Okay, so what are the types of process? There are two types are available. One is the cooperating process and next one is independent process. Okay, so what is mean cooperating process? It can affect or be affected by the executions of another process. Okay, a process that shares data with the other process or share a logical address space, it is called as cooperating process. Okay, so next one is independent process. It cannot affect or be affected by the executions of another process. Okay, a process that does not share data, it is called as independent process. Okay, so process can be divided into two types. One is cooperating process, independent process. Cooperating process, it can affect or be affected by the executions of another process. Independent process is nothing but it can't affect or be affected by the executions of another process. Okay, some examples are available. So first uh, the examples are producer consumer problems. Okay, so this is the process example. Next one is critical sections. Okay, critical sections problem is very important. Each process has a code segment called critical sections. Okay, in which the shared data is assessed. The critical section problem is to design uh, protocol that the process can use to cooperate. Okay, so this is called as the critical section. Consider a system consisting of n process, that means p0, p1, p2, p3 up to pn minus 1, all computing to uses hard data. Okay, so critical sections, each process has a code segment. It's called critical sections. Okay, so when one process is executing in the critical section, no other process is to be allowed in its critical sections. This is the main important point. Okay, one process is executing in the critical sections, one in that particular process, no other process is to be allowed in its critical sections. This is the problem of critical sections problem. Okay, some types are available in the critical sections. Each process must request permissions to enter its critical sections. Okay, so first one is entry section, next one is exit sections, and next one is remainder sections. Okay, so what is the entry section? Sections of code implementing the request permission to enter the critical section. Okay, so what is exit section? That means LS sections of code to leave the critical sections which follows entry section. Okay, it is called as exit sections. What is remainder section? Remaining code of the process after the critical section. So these are all the types of critical sections: entry section, exit section, remainder section. Okay, so next, solutions to critical sections problems. So what are the requirements are available? Okay, so first one is mutual exclusion. Okay, so this is the critical sections problems. If process pi is executing in its critical section, then no other process can be executing in their critical sections. Okay, it is called as mutual exclusion. Okay, so next one is progress. Okay, what is progress? If no process is executing in its critical section and there exists some process that wish to enter their critical section, then the selection of the process that will enter the critical section next can't be postponed indefinitely. Okay, if only one process wants to enter means it should be able to communicate. Okay, if two or more want to enter, one of them should succeed. Okay, so this is the progress. Next one is bounded waiting. Yeah, bound must exist on the number of times that other processes are allowed to enter their critical sections. After a process has made a request to enter its critical section, and before that request is gen- granted. Okay, assume that each process executes at a non-zero speed. Okay, no assumptions concerning the relative speed of the n process. Okay, so this is the bounded waiting. Okay, so some solutions are available. Software solutions algorithm whose correctness does not rely on any other assumptions. Hardware solutions rely on some special machine instructions. Okay, so progress and bounded waiting and mutual exclusions. These are the solutions to critical problems. Okay, so next, synchronization hardware. Okay, semaphores. First, to see about semaphores. What is semaphore? Semaphore is a synchronization tool that does not require busy waiting. Okay, semaphore is a variable that has an integer value, may be initialized to a non-negative number only. A positive integer values is accepted. Next, wait operation decrements the semaphore value. Okay, signal operations increments the semaphore values. Here, two atomic operations are used. One is wait, another one is signal operations. So, wait operations performs decrements the semaphore value. Okay, and signal operations increments the semaphore values. Okay, this is the basic definitions for semaphore. So, what is exactly semaphore? Semaphore is a synchronization tool provided by the OS that does not require busy waiting. Okay, semaphore is a variable that has an only integer value. Okay, here two atomic operations are available. One is wait operation, another one is signal operations. Okay, thank you.